Hello, my name is Matthew Erdman, and today I'm going to show you how to model a rotating cylinder in STAR-CCM. So the first thing you need to do is, of course, load STAR-CCM. You're going to have it installed wherever, so you can load that. Alright, now that STAR-CCM is loaded, just this blank page, I'm going to essentially load in the start the simulation by clicking here and clicking new simulation. After I click this, I'm going to cut to essentially after it's loaded because the POD number is sensitive. So however you would normally load a simulation, whether it would be through a license file or a POD given to you through a course, that's how you would essentially start the rest of the simulation. Alright, once it's loaded, you're going to see essentially it's still loading, so you're going to see a whole bunch of options over here. You should also see here we set a server idle time limit. You should always make sure you have a server idle time limit. There should be instructions given to you either through the software developer or through the course, but you want that to be relatively small. Mine's 0.1 hours, which is probably a little too small, but it's sufficient for this. So again, once this is all loaded, the first thing we're going to want to do is create some geometry. But first, just so you know, you can manage things up through the file menu. Right here is essentially where we're going to be editing everything for the geometry, continuum, meshing. Everything is going to be done through here, as well as options are going to be shown down here. If you don't have these options, you can essentially click the window and enable that properties window to be there or not by essentially using this. You can move this around, save the layout as default if you want to continue to use it. But essentially, you can also show some output in here, which we're eventually going to get to. So this is the way it's set up for me. It might be set up differently than you. If this property windows is not showing up for you, whenever I actually go down to it, you can actually do the same thing by just double clicking on what you're trying to get to. I'll show you that in a second, just in case you guys don't have it here, but I really do recommend that you enable it to be down here, just so it's a little bit easier to see and follow. Okay, so the first thing you have to do is, of course, create the geometry. So if you go and expand this right here, right click on 3D CAD models and click on new. It'll bring you into the essentially software stage, which you could, of course, make your CAD in another program and load it in, but since this is such a simple geometry, it's just going to be 2D. It's easy enough to do it here. The one thing you are going to want to do, the first thing we're going to do is create a sketch. You want to create that sketch in the XY plane. Because it's only going to be 2D, you want everything to essentially exist in the z = 0 plane. So in order to do that, you can just make your sketch on the XY plot. So if you click on there, right click on it, and then click create sketch. Okay, once you create a sketch, you'll see a bunch of these blocks. You can set the width of these blocks by clicking over here on set grid spacing. You can also have some options like snap to grid and so on. Since this is such a simple geometry, we're not actually going to do much of that. So what we're essentially going to do is just create a circle just to start. So we're going to want to position that at 0, 0. Since I have snap to grid on, it'll just snap right to 0, 0, so I can click and then pull it back out to some distance and click again, and it'll turn blue. You want to obviously every now and then, if you click on this and drag it, you can actually change the distance. So of course we're going to want to dimension that, and you can also click on this and move it around. So but we don't want anything moving that, so if you right click on it, you can apply the fixation constraint, and that essentially is making sure that point is always at 0, 0, so it doesn't move. You can't drag it around. You can also right click on this and change it to and apply a radius dimension. I'm going to make the diameter of the cylinder 0.1 meters, which means the radius is obviously going to be 0.05 meters. I'm going to also click expose parameter on both of the dimensions that I use. This isn't necessary, but I'm going to show you why it's useful if you end up having to change your geometry. That way you don't always have to go into the sketch or anything. So we're going to just call this the radius. This dimension will be called the radius of the cylinder, so we'll just call it radius cylinder. So actually we'll call it radius of the inner cylinder. Then we can click OK. So we want another one, of course. So what we can do is just create another circle. So we want it to snap to the same point, the center, and click out somewhere larger. We want this relatively large, so I'm actually going to change that dimension as well. So if I right click on it, well, click on it, then right click on it, and we can apply the radius dimension. If we're applying the radius dimension, we want this to be really big. So I'm going to choose like 20 meters. You can choose something else. 20 meters is probably too large, but for the sake of the course and for the sake of this tutorial, 20 meters will definitely get the job done. And we're also going to expose this parameter and call it the radius of the outer cylinder. So sorry about that. And click OK. Alright, so see, it's huge. It's all the way out there. That's roughly 200 times the inner diameter. So at that point, we're done sketching, so we can click OK. And so we have the sketch. We want to essentially create a surface for it. What we're essentially going to do is create a 3D body, and then it's going to convert it into 2D when we actually do the meshing. So if you right click here on sketch and go down to extrude, you can click extrude. This options will come up. You can extrude any distance you want, but since we're ultimately going to bring it back down to 3D, to 2D, you can just leave all the default settings on and click OK. Alright, so that's all we want for right there. So we can close the 3D CAD at that point. And you'll see right here under the 3D CAD models, there are some options. So you can expand this further, expand the bodies, and you see body 1. So if you right click on that, you can actually make it a new geometry part. So you can click on new geometry part and click OK. Okay, so now you can see expanded down here in the parts. So just to take a look at what we're actually looking at, if you click up here, you can then click to view the geometry. You can twist it by clicking and holding. You can always reset the geometry view by clicking the reset view. You can use the mouse to wheel to scroll in and out, so you can see that little hole in there. So you can also do the same thing by expanding the scenes. It actually, when I did that, I created a new geometry scene. You can right click on scenes and actually create a new geometry scene that way. But since we're just creating a simple geometry scene, it's easy to just do that instead from this menu up here. So anyway, so now that we have new parts, if we have expanded this to the body and expanded the surfaces, you'll see that it's actually all one surface. And we don't want that because we want to essentially be able to label our boundary conditions. So if you right click on that and click on split by patch, you can essentially divvy those up. Now it's important to note that that split by patch option will not be available if you're not viewing the geometry scene. So you want to create a scene first and then split by patch, or else it won't let you click on it. So what you can do is select all the different edges. So if you scroll in here, this out here is 1,4. The part surface name, we're just going to call that outer. And we can click create. The bottom one, so there's a top one and a bottom one. The bottom one was what you're clicking on right here. That's in the z=0 plane. That's going to end up being your body. So we're going to call that just the body. Actually we'll call it fluid. You can create that. There is going to be, if you zoom all the way in, and create this, select this cylinder. That's going to be the cylinder itself. So if we call that a cylinder, the inner cylinder that's going to be rotating, we can click create again. The last one left over, it's not going to let you rename until later. That's okay because it's default. It's also not in the z=0 plane, so you don't actually need it. So if you close out, you see it's still labeled default, but you're not going to end up needing that. So you could rename it, right click on here and rename it if you wanted by going all the way down, but again, it's not going to be needed to be named anything. You could do the same thing with these. If you made a typo on this, you can right click on them and rename them as well. From this point, if you right click on body and go to essentially assign parts to region, so if we assign the parts to region, we want to use most of the defaults here, but instead of create a boundary for each part, we just spent our time undoing that. So we want to essentially create a boundary for each part surface, because we just split it up into different surfaces, so we want a boundary condition for each of those. So if you click apply, and then you can close out, essentially now you see down here, which we're going to get to later on, is you can expand this and see the region. There's a region created for it. So we need to mesh this first of all. So how are we gonna mesh this? We are going to right click on body and create a new mesh operation, mesh, and we're going to create a badge for 2D meshing. Okay, when you click that, you want to select body because that's the only one you have. You can have this checked to execute the operation upon creation. I'm not going to have that checked just so I can show you how to do it, but there's really no reason that you couldn't have that checked and just have it automatically do it for you. So if you click OK, you'll note that there's under here in operations, it says badge for 2D meshing. It has a little explanation point next to it. That essentially means it has to still be executed. So if you right click on it and execute it, you'll see that all the signatures up here changed. This is still gray. That means it's not being used. This is a solid red, which essentially means it's the body of the fluid, and these outlines essentially indicate that these are boundary conditions on the edge of the surfaces. So this is exactly what we want. So the second thing we want to do then is actually assign meshes to that. So if you right click on body again and create a new mesh operation, we want to just create a simple automated mesh. For this one, we're going to just use a polygonal mesher, and although you might not need it, it's always a good idea to add prism layers on the surfaces just to capture your boundary layer. So we're going to also have a prism layer mesher, and you can click OK. Alright, down here you see this explanation point, and essentially if we tried to execute it right now, it's going to probably give us a really ugly mesh. So let me show you what it looks like. When it does that, it's really fast. It will say its executing operation is finished. Take a look at what the mesh looks like. You can go down here and create a new scene of the geometry. You see right here, it completely distorted what your cylinder was. These cells are way too big. It did add prism layers on the wrong side because these are walls. We don't really care about those on the outside. We wanted was prism layers around here, which it kind of tried to do. But anyways, it didn't do a good job at all, is the moral of the story. So this is where we're going to change some of those values in this automated mesh. So if you expand this out, you can select models for the meshing by clicking here. You can select the meshers if you wanted to change your value from polygonal to tetrahedral or something like that. But we're also going to look at the default controls. So if you expand this, these are values that you're ultimately going to play with. The base size essentially is useful in that a lot of these other things reference the base size, so it as a percentage of it. So if you set the base size as 1 meter and you set everything as, like, say 2% of that or 5% of that or something, and then change the base size, all your other values would essentially change in relation to it. So it's really useful to have everything related to that. Or you can just manually set everything to exactly what you want, but every time you change something, you're going to have to change it. So we're just going to change the base size to pretty small, because 1 meter is pretty large, considering that our diameter is only 0.05. So that's what actually I'm going to make the base size. Actually, sorry, the radius is 0.05. The diameter is 0.1. So anyways, we're going to make the base size 0.05. Again, you can make this any value you want, but you're ultimately going to want to play with it to make a good looking mesh. So you hit enter. And you can essentially, we're also going to want a target surface size. So what we're going to do is actually we're going to add a specific surface control for the inner radius, but for the outer radius, we just really want it to expand out to that value. So we're going to just say the target surface size on essentially the outside. This is going to originally be to all surfaces, but since it's the default control, and if we don't define anything, it's just going to be the outside, because if we define something for the inside, it'll essentially override the default control. So we're going to make the percentage of the base, which is going to again be applying to the outer one. We're going to make that really large, because we want those meshes to get pretty, especially expand outwards. So we'll make that 3,000. Again, these are numbers that you can play with depending on your geometry. We also want the number of prism layers. So the prism layers on the inner wall, we're going to want that to be roughly 6. You can change that to whatever you want. And also, just from experience, since we set our base size to 0.05, the percentage of the base that we want for the prism layers is roughly 5%. That's just from trial and error. What you would do is you would mesh this several times and kind of take a look at it, or figure out how long you want it to be. And you can also, if you click up here, you can actually click and actually change it to absolute, which allows you to actually set the absolute size. But again, the relative, you can just set it as a percentage of the base. That way, if you ever change the base size, this prism layer thickness would also change with that base size. So as I said before, we're going to add a surface control on the inner surface right here. So if we right click on custom controls and create a new surface control, essentially what this surface control is going to enable us to do is essentially make a much more divisions around this cylinder. So if you expand this out, actually if you click on the surface controls, down here you're going to want to get the part surfaces. So there's nothing listed here. So if you click these dots next to it, you can expand this. You want essentially to add a surface control onto the cylinder. There's a blue next to what you selected, and you can click OK. Again, if you don't have this down here and you needed to click it, you can just double click on this. It'll pop up, and you can click it over here. Again, so if this isn't down here in your properties, you can just double click on it, and it'll pop up the screen. But again, it's just easier to not have to do that each time. So for these surface controls, what we're going to do is we're going to add a target surface size. It says all the defaults are always the target surface size of the parent. That means essentially of the default controls. So we don't want it to be a default control target surface size. We want it to be custom. And you see down here, if you expand this tree, the target surface size is now down here, and you can change the relative size. As a percentage of the base, it's going to be easier since we want exactly 100 divisions all the way across. Instead of relative to the base, we can actually are going to select that as absolute. And then if we click down here again, what we're going to do is I'm going to make this 0.00314 314,159. Essentially, this is essentially the correct size so that you're going to have 100 divisions all the way around the circle. So that's just calculating with a 0.1 diameter, cylinder. That's how many essentially each division you'd have to make. So you can hit enter. And so what we're also going to do, we don't want any prisms on the outer cells. There's really no reason for them to be there. So if you create another custom surface control, so if you right click, new surface control, and we're going to change this on the outer, so we can click OK. expand, it'll give a prism layer. Again, it's again based on the default settings, which you set as 6. You can click down here and you can actually disable it. You could change any of those values if you wanted to, but we don't want them at all, so we're just going to disable them. And so that's all we're going to do for that. And so what we can do from there, we've changed all these. There's still the exclamation point. If you right click on this and execute it, it's going to take some time, and you're ultimately going to get a cell that looks like this. This expands too fast though. Look at how big it gets pretty quickly. So what we're going to do is if you go back to your default settings, which are default controls right here, if you go to essentially surface growth rate, and change that to a much smaller value. So the growth rate from the surface, we set 100 divisions. We want it to grow much more slowly than the 100 divisions around here. So we're going to set that to 1.05. So if we hit enter and then essentially execute it again, it'll get a much better mesh. You can execute it better as well by just clicking here and clicking generate volume mesh. It'll take much longer, but that's because we're creating a lot more cells. It's still a relatively short simulation. So you see right here, it expands outward, so really close, has a bunch of small cells. You can see the prism layers right here transitioning nicely into the polyhedral mesh, and going out, expanding all the way to the outer out here. Alright, so that's going to be the good, like a good mesh for right now. You can play around. The finer you make it, the longer it's going to take, but the better answers you're probably going to get. So keep that in mind. It's generally a trade-off. I'm going to save it right now, so you can file, save as. I just don't want it to be lost. So we're just going to save it, tutorial 2, because I have several tutorials. So always make sure you save it from different steps. You never know when something's going to go wrong, or you're going to want to go back to it. So now that we have a complete mesh, what we want to do is define essentially the continua, or the physics of the system. So if you go down here and expand the continua, we're going to subtract some of these, minimize some of these so you don't see as much. If you go to the continua and expand physics and right click on models, you can select the models. So we're just going to do a steady simulation of a liquid. All of these options exist. You will note that two-dimensional is already checked under enabled models. That's because I have this checked down here. It auto-selects the recommended models and knows it's a 2D simulation, so it's solving 2D. So anyways, so we can click liquid. We're going to use segregated flow. The equation of the state, since it's just going to be liquid anyways, it's just a constant density. We're just going to have the viscous regime laminar, and none of these we're going to enable right now. These are options that you could use for much more complicated solutions. So we can close out of that and expand the models. For the liquid, you'll note if you expand that it gives you, that assumes it's H2O. If you don't want it to be H2O, you can either replace it with or rename it. We're just going to rename it as essentially viscous fluid, because I'm going to change some of these values, so I'm going to call it viscous fluid. So if you expand it down here, you can actually still see the material properties. The density, it's almost 1,000, but we're going to just make it exactly 1,000, just for math's sake. And then you can also change the dynamic viscosity. I'm going to make this super viscous and just make it 1. So again, you can play with that as needed for your simulations. But that's all we're going to need right now to set up the models. You could have, instead of laminar, you could have expanded this and chosen some turbulence models. You can also essentially set some initial conditions of velocity and pressure, but it's just already just going to be not moving. Everything outside is going to be not moving to start the solution, so it's not super important. So now if you expand these regions, you can, if you expand these regions, you'll note that essentially we do have four different things. This default's not supposed to be here. So what you're going to want to end up doing is deleting this region since we did it too soon. So if you delete the region, we can click OK. Go all the way back up to your parts, expand that for your body 1, and we can essentially assign the parts to the region, create a boundary for each part surface. Ultimately, you should have done that at a later step. I did not, and so I had to redo it. If you expand these regions now, you'll see that there are just 2 boundary conditions, which is what we want. If you click on them, you can actually change them to different specifications. So wall, if you wanted to, what you can do is actually when you expand this, you can set the tangential velocity specification. It says it's fixed, but if you actually check it to a rotation rate, physics values will come up down here, and you can set the rotation rate right now it's set at 0. We're just going to set it as a relatively low rotation rate as 1 radians per second. That's something you're going to also want to play around with when you're trying to solve this. The wall itself, the outer wall, you can change the physics conditions. We are going to set the shear splash. You can set it under no slip, but we are actually, since the wall is so far away, we're actually going to leave it at no slip. But those are just options that you have. So leave it at no slip for now. No need to overly complicate things. Everything's far enough away. To the shear stress specification. Alright, so I don't know if you noticed, but when I actually deleted the region, the mesh scene disappeared. That's because you have to have things assigned to a region while you're meshing. So this is an important lesson, which is why I did not edit this out of this video. So essentially, since I deleted the region, if you expand these operations, you'll see that there's an explanation point next to automated mesh. So you want to right click on it and you want to execute it. And so you're essentially running it again with the new region. So after you do the badge for the 2D meshing is when you want to assign the parts to region, and then when you're doing the automated mesh. I did not take that out, although I hope it might confuse you guys a little bit. I just want to make sure that you guys understand that some of these orders for things actually do matter. And so after you create the badge for 2D meshing, that's when you could right click on the part, essentially assign parts to region, and then after you assign the parts to region, then you have to right click on it and create a mesh operation and an automated 2D mesh. So the order goes badge for 2D meshing, then it goes assign parts to region, then it goes automated mesh. If you don't do it in that order, you're going to have to delete things or restart things, and your mesh scene will disappear. After you ran it, you can now click and create a mesh scene, and you can see that your mesh is exactly the same, but ultimately it's now you have the correct region. And so you just always want to make sure that if you delete something or change something, that it hasn't created any explanation points further up your process. Hopefully I did not overly confuse you by removing all those steps, but I made the mistake, so I wanted to use that as an opportunity to make sure that you guys did not make similar mistakes. So now that we have this mesh, we have the region set up, what we're going to want to do is, first of all, we're going to create some derived parts. So if you right click on this, you can create a new part. We're just going to create a line probe. So what this line probe is going to do is essentially take data at a certain point. So if you click on this, it'll give you all these options. You can actually physically twist it around. I'm just going to type in the values that I want. So I want it to go essentially from roughly x equals 0 to x equals the outer the outer radius or diameter. So we're going to make that 20. We're not going to, everything else is going to be 0 though. And so essentially this is just taking the line from the where your inner radius is all the way out here. The resolution, this is essentially the number of evenly spaced data points it's going to take all the way across the top. I'm going to set this at relatively 2000. You can add these essentially probes after running the simulation, but I'm going to use them to show you that actually as it solves, so it's a good idea to do so beforehand, but you can do it after the simulation. This is just for data collection purposes. I mean data showing purposes. So we can create it and close. So there's a bunch of data points. Essentially it's going to take a data point at essentially the velocity at each of those points all the way across. So what we're going to do, if you expand this solvers and expand segregated flow, when you click on the velocity and the pressure, here are your under relaxation factors. I'm going to keep them at 0.7 and 0.3. Essentially the lower it is, generally the more stable it is, but the longer it takes to converge. So if you're having trouble with convergence, it's just not doing well with complicated geometries, you can change these, but ultimately for this geometry there shouldn't be too big of a reason to change these, so we're going to keep those exactly the same. We're also going to change the stopping criteria. So if you expand this, the maximum steps it says it'll stop at is 1,000. So we want to create that pretty big, because what we wanted to do is not to stop on maximum steps, but we wanted to stop when essentially the residuals are too small. So the residuals are essentially sources of error, essentially the change between numerous iterations. So if you make the maximum steps really large, and right click on stopping criteria, create new criteria from monitor, we want the continuity. We're essentially going to create a monitor for the continuity, the x momentum, and the y momentum. So we're going to have to do this 3 times. So just the continuity, you can click OK. You see that the minimum limit that you want it to be set to, we're going to set this really, really high. It'll tell you when it's stopped. You actually probably should go higher than this, but I'm just going to set it to 1 times 10 to the negative 8. You can even set it even higher than that if your answers are still changing. So we're going to do the same thing for the x and y momentum. It is important to note, in a second I'll show you after I do the last one. So again, right click, create new criterion for monitor for the y momentum, the minimum limit to the 8th. You want to click on each of the criterions and change the logical rule to and. Essentially that way what we're making it mandatory for the continuity, the y momentum, and the x momentum to all have that essentially criterion satisfied before it stops the solution. Because if not, if one of them hits it but the other one has like huge residuals, it'll still say the simulation is converged and it'll stop, even though one of them is really bad. So you want them to change all of those to and. We're also going to add some plots just for viewing purposes essentially. So if you subtract it out, down here is some plots. So if you expand this, it automatically is going to give you a residual plot. But if you right click on it and say a new plot, you can create an XY plot. The X type is just the direction essentially, so it's in the positive X direction. The Y, if you expand this down here, is a scalar function. If you click the ... next to it, we're going to make it a scalar function of the tangential velocity. So you can select that. Again, blue appears next to it. You can click OK. So you can change the units as well. So this is just going to be a plot of the those. And so you notice it appeared up here in our scenes window. So for the XY plot, what you're actually going to want to do also is make sure what's the XY plot on. If you click on it and you go all the way down here for parts, again, nothing selected. So if you click the ... we're going to actually make the XY plot on that line probe. So we're just going to see the tangential velocity as it goes across. So we can click OK. But if you want to see the contour plots, that's when we're going to create scenes. So if you scroll down and right click here and create a new scene, a scalar, you'll see down here a new scalar scene has been created. You can rename this so that you know it's tangential velocity, and hit enter. And if you expand this open for distributors, displayers, scalar field, again, you can double click on this to have this pop up. I don't like that, so just click the dot 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 next to it. We're going to create tangential velocity and click OK. Alright, so now we have a tangential velocity. Nothing's been run yet, so it doesn't have any tangential velocities. At this point, what we can do, just for the sake of it, we're also going to do velocity vectors, just so you can see what they are. So if you right click on it, new scene, vector, very much the same. If you can right click on it and rename it or expand it, go down to vector, all the way to vector field. It automatically set a velocity, so that's what you want, so you can just leave it there. But if you wanted to change it to some different vectors, you could do so. So anyway, so now that that's all there, we have all of those scenes up here. When we start running it, the residuals will pop up as well. So the first thing we do is click this green arrow, green flag, to initialize the solution. And then what we can do is start to run it. So if you click this run button, you'll notice the residuals pop up and are going. You can see the residuals also going down through here. You want this to be relatively stable. If it's not stable, see there's a little bit of bumps there. That I'm not super concerned about those yet, because it's still at the early part. But ultimately, you can refine the mesh, change your mesh, make sure there's no essentially bad mesh things, or change some of your under relaxation factors. Also, you can take a note, the vector scenes, you can see if you scroll in here, so it's kind of hard to see. So if you actually expand, you can alter any of these as you actually do it. So if you expand this vector scene, displayers, the vector, so for the vector field, if you scroll all the way down, if you expand this option for the vector field, if you expand this, the relative length as a percentage, let's just make this relatively small. So we're going to make this 0.15 or something as a percentage. Hit enter, and if you zoom in, you can actually see, so that wasn't great either, but you can actually see it spinning around. You can see all those vectors. It's really crowded because there's so many cells, so if you make this even smaller, you might be able to get a decent view of it, but you'll be losing. Essentially on the outside, you can see it essentially is adding a bunch of vectors as it swirls. You can go to the tangential velocity as you zoom in. So this is a contour part of your tangential velocity. You notice it's still changing a lot. So the residuals are still going down. So what you ultimately want is a solution in which the residuals are really low and that none of these values are changing. So that none of these essentially is expanding outwards or anything. You want this to be relatively steady. That way you know that essentially you couldn't run more iterations and get a different answer. Also the XY plot, you can note right here. You note that we didn't really take enough data points up here. So you would essentially fix that by taking more, a higher resolution. So if you go to this derived parts, line probe, you can change this resolution. We're going to change it to, like, say 4,000. You see it's adding more. So this is changing in real time for you. We can even make it like 6,000 or even 10,000 to get a lot of data points up around this point. You can use your mouse button to scroll in, or if you actually go to your XY plot and you expand the axes and click on this, you can actually set the minimum value and the maximum value, and you can lock them if you want. So I'm going to lock them at 0, and I'm also going to change the maximum value because I don't really care about all of these zeros. I'm going to change the maximum value to about 3, just to save it so I can take a look at it and lock it. So this is what it's looking at. You don't want any of these points moving. Essentially what it comes down to. Oops, I didn't lock it. Anyway, so you don't want any of these points moving, but ultimately this is what you want. You will note if you scroll in, essentially these are all in the same cell, which is why they are all there. So you want to take that with a grain of salt. You're only as accurate as your resolution of your cells. But this is a pretty smooth looking curve. If you take a look at the residuals, you're going to get a screen like this continually going down. Looks like there was some unsteadiness in here. Again, unstableness in the solution. As long as it's ultimately converging, these are just minor hiccups, that's fine. So what you're going to want to do is essentially keep this running to completion until none of these values are also changing. So it's changing pretty slowly, but it's still changing. So we're going to let that run for a while, and I'll get back to you. Alright, so I stopped it at this point. You would obviously want to continue running this, but I was checking these vectors. They weren't really changing. This wasn't really expanding much more. These weren't changing. And besides, this is really just a demonstration video. The actual values don't matter as much. But you would continue changing these all the way to the end. I will tell you that this is not normal. I got a little impatient waiting for this to end, and was looking at some settings and accidentally changed something and had to change it back. Essentially it would normally just continue in a straight line here. If you accidentally change settings because it is real time, these will appear, and you don't want to be changing things at this level too soon. So make sure you're not running things or when you're changing things, or that'll happen. It's not super bad, but it just doesn't look great for the residuals. Alright, so now that you're done, we can again look at this XY plot, this tangential velocity, the vector scenes. These are all things that you could have then actually done at this step. So you can create any of these vector scenes or create a derived part, create a plot of everything. But just because it was easier to monitor and actually look at it as it's actually happening, that's why I told you to do them earlier. One last step that I want you guys to do, that you guys should probably do, if you want to export this into Excel, you can export it into, so we can change the file name to tangential velocities, and we can save it. And if you then open it, it is a separated CSV file. You shouldn't double click it numerous times like I did. But anyway, so if you look here, here are all of your probe values. So you can then plot these and plot them with relation to everything else. If you wanted more data points, honestly, the more is better. So you could honestly change this. The settings, remember when I could, the derived part, I checked it to 10,000. You can make this as large as you want. It's just going to literally change the number of tangential velocities. You could also set the probe for a shorter distance, since you don't really particularly care about the velocities way down here. But that's up to you. So anyway, so that's all you're going to want to do. You are going to want to save it, save your data, after exporting it, plot it. That's about it. If you have any questions, please leave them in the comments below. I will try and do my best to answer them from time to time. No guarantees. And good luck with the rest of this course if you're taking this for a tutorial, or if you're just trying to solve problems. Good luck with those as well. Thank you and have a good night.